Hello and welcome to this backend tutorial video. Today we are going to talk about caching, everything to know about caching, and it's going to be an introductory video. So let's not waste time and get right into it. First, in this video, this is what you're going to do. We're going to understand why we need caching. We're going to talk about the caching validation strategies. We're going to talk about the elimination strategies and how to implement caches in Python. This will be done practically, so stay tuned. I think that would be fun. So what is caching, or what is a cache? For those of you who have done computer, you know that there's an existence of a cache memory, and a cache memory is defined as a fast memory that is used in the computers to store data that is required frequently. So by division is that caching is a technique used in computing to store copies of data in a temporary storage location, or a cache. That is what I've talked about, the cache memory, so that the future request for that data can be served faster. The main goal of the caching is to improve data retrieval performance by reducing the access time and reducing the load on the primary data storage, for example, the database, etc. So as you can see, I have two diagrams. So one is a diagram with just a client interacting with the database, and then another one is for the client interacting with the cache, then the database. These two structures, architectures do the same thing, but one has an advantage over the other. So we all know that making requests or making API calls and everything, seeking data from a database, it costs us money. So example, if maybe this is an API call, you make a request to some database somewhere through an API, you have to pay for that call. So making this request to database back and forth, it first of all, it may take much time accessing the database each and every time, and secondly, it is costly because of each and every call, each and every request you make, or each and every request you send, it will cost you money. But for the second architecture, you'll see that there's a cache in between the database and the client. So when a client makes a request, first it checks whether the data that the client is looking for, or the person is looking for, is present in the cache. If it is present in the cache, then they don't need to go all the way to the database to find the data. They just, if the data is present in the cache, it is sent back, which is more faster compared to going all the way to the database. And also we have saved money by just accessing the data that is present in our cache memories rather than making another request to the database. So if so, we have several caching strategies, and that is what we are going to talk about in this video. First, we have the write-through strategy. I think the write-through strategy is that it's just similar to what I've shown. Data is written on both the cache and the backend store at the same time, and this ensures data consistency, but it can be slower. So when you write data, when you're sending a write request, if the data is not in the cache, it will be written into the cache and also written into the database, and then you get a response back. So that is how the data is written into the cache. So when a write request is made to the database, also the cache gets updated, ensuring that the data is consistent. That makes sure the data present in the cache and the data present in the database is similar, so you don't have conflicting data within the database and the cache. We're going to see in the next we're going to see how you can have inconsistencies in your data. For example, when your cache goes down and you are making a request, the request will go directly to the database. Maybe it's a write request. So when you update the database and not update the cache, we'll have inconsistent data between the database and the cache. So that's what I say. Writing the write requests are made to the database and the cache, ensuring data consistency. So the other one is the write around. The write around is where data is written directly to the backing store and bypassing the cache, and is useful for writing heavy operations where caching will not be beneficial. So when the data when first of all, when a client is making a write request to the cache, if the data is not present in the cache, it will not be written in the cache. It will be written to the request will be sent to the database, stored in the database, then the response sent back to the client that has been stored, then the data will be saved in the cache. Because how else would the data be written in the cache? So there is saying that it is used to writing heavy operations where caching will not be that beneficial. And then the last one is the write back cache, just like the write through cache, but not writing the database, but it is just like the write through cache, but writing to the database happens asynchronously after a short delay. I hope I've given the right pronunciation for asynchronous. Then after a short delay, the data is written to the cache and then to the backing store at a later time. Improves performance but can risk data loss if the cache fails before the data writing occurs. So in the previous day, the caching, the write through cache is the write back cache is just similar to this, but when you write the data into the cache, it does not get written to the database instantly. The data will be written to the cache, then the response will get back to the data to the. This makes point 4 faster compared to the write through, where we also say that this is slower. So the data will be written in this cache, then it will be written to the database at a later time, not at the same time when you are sending the data to when you are writing the data to the cache. So to the backend, the data will, to the database, it will be written later. To the cache, it will be written instantly. So based on maybe for some reason the cache goes down, maybe power goes down, there's some power issues with the cache and the cache memory and everything, and the data has not been written to the database, you might lose your data here. You might lose your data that you written to the cache. So the database will remain the same. The data will not be updated. So that is the risk of using the write back cache, but it is faster compared to the write through cache. Next, we're going to talk about the cache replacement strategies or cache elimination strategies. First, we have the list recently used. It evicts the least recently accessed item first. I think most of these replacement strategies are self-explanatory. You can just it's something that you can just read through and understand how it works. So it evicts most recently used item first. First in, first out. This is like the queue system. First in, first out. The least frequently used evicts the item that is accessed least. You might realize that least frequently used and least recently used, they are more of the same, but there's a small difference. One one deals with time, and the other deals with a counter. The one that has been frequently accessed, the one that is least frequently accessed gets removed, and for the least recently used, even if you access it frequently, but compared to the others but have not used it recently, it will get eliminated. And then the other one is the random displacement. So the cache information will just replace any random any random info that is present in the cache. We'll see how we can use the list recently used in when we'll be implementing our cache. So what happens when what if the cache goes down? So as I explained earlier, that these caches sometimes go down. So you must set time to leave so that you must set a time to leave so that you can clean up your cache and update it after a specified amount of time. Maybe it could be 10 minutes, maybe it could be an hour, depending on the architecture of your application and how your application works or how your website works, or you have to like give it time, because sometimes the cache, something might happen to the cache, somebody might clear it. You've seen the website saying your maybe if your memory is less, you'll see giving you'll see a suggestion here telling you that you should clear your cache or something. So when you clear your cache, how does it get updated or something? So you can do it manually or you can automate it. So that we'll see how we can do that in our implementation. And then we have the Redis background scan. Redis, I will not talk about Redis much. I want this to be more of an introductory video. But Redis is also Redis can be used to scan the Redis scanning can be used to scan. If you create your cache using Redis, you can get if there's a scan feature or a scan command that you can use so that you can it scans the database, figures out what has been updated or should not be updated, and updates your cache accordingly. So if the cache goes down, there's a way there's a, an auto, there's a way so that you can update your cache each and every time. Then implementation. Cache implementation is very easy, and currently there are lots of existing solutions to caching. So you can use the Redis cache. Redis is very powerful and is highly recommended. If you go and search caching and everything, you'll see that Redis is mostly used for caching and other apart from other things you can do. So you can use Redis caching. There's Vanish. There's a Node cache. Oh, Vanish. I think I wrote that twice. So Vanish and Node cache and Vanish again. So these are some of the things that you can use to implement your cache. And cache implementation that is very caches applicable everywhere. The quickest answer is no. When your code when there's no difference when you have a cache and you don't have your cache in your code, you probably don't need the cache because why put it there when you don't actually need it. You'll be just increasing the amount of code or writing more code for no reason. So if having a cache in your code does not affect anything or does not does not change the way your program works, then maybe it is not that of a necessity inside it. But I'm saying if it's not that bad to have one in place in case you might require it, but you might not need it. And then caches are used to store, mostly they store data that does not frequently change. So when you're having data that is highly random, it means that your cache will always be updating. You'd rather have something that is constant in your cache so that when you can access, you don't have to keep on updating the cache because now you'll be making the cache to be just some sort of different database because why? Because every time you update it, you have to access the database. So if you have to access the database every time, why do you even need the cache then? So caches may not be applicable when you have some highly random data. For example, messages. No, it kills it kills the essence. So when you have frequently updated data, yeah, of course. Also, when you have data that is always updating, I used an example of comments. Comments are always updating, Each and every minute there's a comment, a new comment, a new comment, a new comment. So frequently updated data, you probably don't need a cache unless it's some specifics. It entirely depends on how you've implemented your application, whether it's a web application, how you implemented it. That is all that matters. So I hope you've learned something from that. Then the next thing you're going to do, you're going to implement our solution with Python. I think I'm going to I'll first I will make a solution with Python. Then we will implement our own cache system using JSON. You can see how you can create your own cache using Python and JSON. And then, as I said, for implementing a cache using Redis, I will create a separate video for that so that you can learn how you can use Redis to help you create your cache, implement caching in your programs you're going to build. So let's dive into it. Okay. Okay. So we'll go through how we're going to go about this. So as I said earlier, we're going to implement what you do from what you planned. We will implement a cache using Python, then create our own personal caching system using files. Let's say JSON files, using JSON files, but you can choose files of your own. And then we can also but this implementation of caching using Redis, I say that create a separate video for that. So let's get right into it. So we'll go to this file. First, we implement our cache using Fibonacci. So for the Fibonacci sequence, how it works. For the Fibonacci sequence, for you to get the next number, it is the addition of the two previous numbers. So for example, if you want to get the Fibonacci of 5, you have to get the Fibonacci, the addition of 3 plus 4, that is 3 plus 4, 2 plus 3, that as you go back and forth. So you realize there's something that we have to do. First, to get the Fibonacci of 5, maybe 3. You'll have to know the Fibonacci of 1. You'll have to know the Fibonacci of 2. So first you're going to define the form function for creating the Fibonacci numbers. So we'll do fib of n, then n is equal to 1. You all know that Fibonacci of 1 is 1, Fibonacci of 2 is also 1. Is equals to 2, you return 1. We return 1, and then else return the Fibonacci fib of n minus 1. Then we add it to the fib of n minus 2. Yeah, I think that will give us a Fibonacci sequence. So if let's try it out first. If I print the Fibonacci of 5, we'll get, let's run this. See, Fibonacci of 5 is grows as the number grows bigger and bigger. It takes more time to process it. So I'll import time here so that you can see how much time it takes to process the bigger numbers. Let's import time, and then we're going to use this time to, let me just say, start equals to time dot time, and then stop. So it's the same thing. Yeah, so that will give us, let me also print start and stop. So if we run this, you can see it has taken very less time to run that. So you're going to realize that without the we've not created any cache yet or used any cache yet in the meantime. So let's try you see for 7 it's taking shorter time. Let's try a value 20. We do the Fibonacci of 20. Let's see how much time it's going to take. And see it's taking less time. If we do no, this is wrong. This is wrong. Something's wrong. Supposed to be stop minus start, not start minus stop. That's why I'm wondering why am I getting negative numbers. So stop minus start. Yes. So let's try this again. Yeah, so you can see it's taking 0.3 seconds to run that. So if we increase the numbers, let's go to Fibonacci of 30. You can see the time is growing as the numbers grow as we get to more larger numbers, the time is also increasing. You can see now it's taking 0.3 seconds. Let's do the Fibonacci. Let's just increase this by 5. You know, the loop that occurs here, it grows exponentially. So even if we increase this number by 5, the, the, the loop also takes more time to process it. So let's do Fibonacci of 35. You see, we are waiting much longer compared to Fibonacci of 30. So you can see the Fibonacci of 30, it took 0.39 seconds, but the Fibonacci of 35 is taking 4 seconds. 0 seconds, and this is taking 4 seconds. So you can see it takes much time as you go further. So let's try Fibonacci of 40 and see how much time it takes. You can see it's loading. It is taking quite much time. As we wait, I'll talk about now the inbuilt caching system for Python. So it's not really a caching system, it's just a tool that was written that helps in caching. So we can see here, for you to use it, you'll have to import something called the functools from Python, and then from functools you'll import something called, not functools, we'll say from functools, let's use from functools, not import. From functools we'll import cache. As you can see, I've talked for for a while now, but the process is still not done. Yeah, you can see it's now done. It has taken at almost 1 minute just to do the Fibonacci of 40. That is 51 seconds. That is almost 1 minute to do the Fibonacci of 40. Now let's see with the cache. This is a cache property. This it's called a cache property that we're going to introduce here and see how much time it's going to take to run it. So if I introduce, so this property you always put it at the top of your functions. So for example, you want to make this function cacheable, you just introduce here cache like that, like that. So if by putting that there, if we try, remember previously we saw that it took how much time? It took, it's not bringing. It took 51 seconds to do the Fibonacci of 40. Let's see how much time it takes when you do the Fibonacci of 40 using when we are now using the cache. So if we try, we are now that we've introduced the cache, let's see how much time it takes. See, with the introduction of the cache, we are now taking 0 seconds to do the Fibonacci of 40. But without the cache, it was taking 51 seconds. If we also try even 400, see, for 400 is taking 0.2 seconds. That is also giving us this value. So you can imagine without the cache how much time it would have taken to do the Fibonacci of 400. I think so the introduction of this cache has brought us to something, has reduced the time taken to process that value. So we're going to remember the least recently used cache. I want us to try that. So the least recently used cache, this just it's going to do the same thing. You just replace this with the LRU. I'll just replace it with the LRU cache. So it's not going to change anything. It's simply a cache, but this one obeys the least recently used. So it will do the elimination. So for right now, for these values, the cache stored each and every value that was being put to it, but we can limit that. See, we can use the LRU cache and we put the maximum size, let's say 10. So it will be storing only the 10 previous values of the cache. Let's say if you have the numbers, the the, the Fibonacci of 40, so it will store maybe the Fibonacci of 9, 14, 39, 38, 37, 38, 6 to 30. Then the rest will be eliminated away. So this helps us in clearing some memory so that it does not clog up for no reason. So I don't do anything different, but it's just documentation about the functools, how it is used, what you can do it with. But that is how you can implement a cache using the functools in Python. Let's go to the next one. So I also created another file here. This is the next one is called file caching. So we're going just to dive into that right away. Okay, so the next thing we are going to do is to implement our own cache, as I explained. We are going to try to create our own cache in our file storage. We are going to use an API I created. It's called the Idea Guy API. Idea Guy API is an API that gives you random ideas. If you are a developer and do not have any idea of what you want to build, you can use the Idea Guy to give it to you. I will share the link with you. So from this API, I will try to get the users, but I will just do it from my local host here, and so that you can see how we can fetch from APIs, then create our own cache, so that you can create our own caches in our files in our computer. So this is how you can implement your own cache. Let's first of all let's first import JSON. You're going to use a JSON file. I'll import JSON, then I'll also import requests, because request is the one which is going to help us access the API. Yes. So I'll create a function that gets data. It's called this function get data. Then in this function, we will try to open, first of all, we will try to open a file. We'll try to open, we'll put this into try and accept block. We'll say open first we'll say try to access the local cache. So our local cache will be in a JSON file. So you'll try to open the cache first. they will call it cache.json, JSON. Then try to engage, we'll open it as read, and then let's call it, let's just call it file. Then we'll try to do JSON.load. This is reading the file itself, file. So yeah, this way, if the file will be existing in our local file, we'll open it that way. I'll try and put some print statement. I'll do that later. Then with open file JSON, gcast.json file, then json.load file. If the file is not in our local file, we'll accept, just use exception. So if the file is not in our, if the file is not in our local file, what do we do? First, we'll try to get the data from the API. So here we'll do json.load file. So we'll say data. The data is equal to json.load that file. Then we'll try to get this data from the API. So what we'll do, we'll use the request method, requests.get. I have my server running on my local host here. So what I'll do, I'll just find, let me just get it from my, to the HTTPS localhost, then /8000. It's a fast API file, so I'm just running it on my port 8000. Then we'll get the users. So request.get users. So we'll say request.get users. We'll say data is equals to request.get users, and then we'll do data. Let me use this. Change this to response. Let's just put r is equals to request.get users. Then data will be equal to r.json. Then we'll open a file. So we'll open a file. As we said, we'll call this file a cache.json. Then it will be a writable file. Then we'll open it as cache. We'll call it a cache. Then do json.dump. This is now writing our cache into the file. So we'll json.dump the cache. Then we are dumping data. We're dumping this data. The data we retrieved from the API. We dump it into our JSON file. So we dump it into the cache. And then we'll do an indent of 4. So if you don't understand what's happening with JSON, you can go check JSON, check out JSON, the JSON documentation, or you can find yourself some other documentation you can read so that you can understand what is happening here. But basically, we are just trying. I believe when you're trying to get to know about caches, it means you already know about JSON. If you don't worry. You can get this from anywhere on YouTube or Google. So we'll dump our file json.dump data. So that after we dump the data after we have dumped our data into the JSON file, we can now exit this. I think I'll add in some print statements so that you can just see what's happening. So I think this is the function that will be getting data from JSON, saving it. Then after that, at the end of it all, we will return the data. Return data. Yes. Return data. Yeah. So I think this is it. So let's try this out. We can call this function. We can do print. You can say we'll say users is equals to get data. Then we can put there print start time, can say start is equals to time. Then stop will be the same. Can stop here. So obviously I have to import time. Then yeah, I think this is it. Then we'll print, let's say for user, I think this will do this here. For user, in users, print user. Then let's get email from that data that we have received. We'll print the email. Then finally we print the time taken. Stop. Start. Yeah, let's try this out. Let's run Python. Cache file. So let's see what happens. See, the cache is not found, so it's trying to retrieve the data from the API, and that is a very big error. Let's see what's saying. What is the error trying to tell us? The error is trying to tell us that from get data, okay, it says that sorry. Okay, I can see that what I can see already see the mistake I did. I believe you also saw it. This is what I did. Instead, this is supposed to be a colon, not a slash. So instead of using a slash here, I used a colon. Instead of using a colon, I used a slash there. So maybe that's why the error was there. Let's try running this again. If we run this, yeah, you can see retrieving data, cache not found. So after, let me just take you through what happens. It tried to receive data from this write exception, so the data was not available in the cache. Then after that, it went to fetch the data from the API and told us that the cache was not found. So after fetching the data from API, it printed done fetching data from API. Now creating the cache that we had created. After creating that cache, then it returned the data that was. Then we stored the data into the JSON file, and then returned cache created. And then after that, I wrote this loop that was accessing that function. So from that, it had printed as this three email, and all that process took 2 seconds. So you can see when if you come to this file here, you'll see that there is a cache here, and you see this cache, you'll see a JSON file that is present here. Now, that is a local cache we've just created ourselves. Now let's try accessing that cache and see how much time is going to take us. If we are using, if now instead of accessing the server, we access the cache. So if I run this again, you can see it now comes immediately. So all this previously took 2 seconds, but by using the cache, it only took zero. This is probably 0 seconds, 0.007 seconds. So we can say 0 seconds to get the data. So we are getting the same data, but faster. So that is how you can implement your own cache. So next next up, I will try to show you how you can create your own data, your own cache using the Redis. So Redis, I'll try also to make you understand how Redis works, what are the functions, the commands, Redis commands. Then from there we can be able to create our own data, our own Python cache using Redis. Thank you, and I hope you've learned something.